We're looking at a piece of hardware that, I mean, on the surface, it looks pretty boring.
It's a cable. A 65-foot DVI cable, to be exact.
A 65-foot DVI cable that costs $545.
Right. And that price tag usually gets one of two reactions. Either that's a total ripoff,
or what on earth is going on inside that cable?
Exactly.
And that's our mission today. We've been digging through the spec sheets directly from the manufacturer, NTI, to figure out why a cable would cost as much as a new laptop.
And the first thing you realize is that calling it just a cable is not quite right.
It's a bit of a misnomer, yeah.
It's really an active signal processing system that's just disguised as a cable. It's what's called an active optical cable, or AOC.
And that's the core technology here, because if you cut open a normal DVI cable, you'd just find copper wire.
Mm-hmm.
But if you cut this one open, you find this hybrid of copper and glass, fiber optics.
And that hybrid design is really the whole secret. It divides up the work. The heavy lifting, we're talking the actual red, green, and blue video data, plus the clock signals.
The important stuff.
Right. That's not sent as electricity. It's converted and sent as pulses of light over the optical fiber.
But they did keep some copper in there.
They did, yeah, for the DDC signal.
It's display data channel.
Exactly. That's the little digital handshake where the monitor says to the computer, hey, I'm a 1080p display.
Yeah.
That's super low bandwidth, so copper is fine for that.
So for the high-speed video, there's active circuitry involved. The specs list an 850 nanometer VCSEL optical source,
which stands for vertical cavity surface emitting laser.
So there are actual lasers in the connector heads.
Tiny little lasers. They take the electrical video signal, turn it into light, shoot it down 65 feet of glass, and then a PN diode on the other end turns it back into electricity instantly.
Okay, but why? Why go through all of that trouble? Why not just use a really, thick copper wire?
One word: noise. That is the enemy over long distances.
Electromagnetic interference.
Exactly. Copper acts like a giant antenna. Yeah. If you run a 65-foot copper cable next to, say, power lines or heavy machinery, it's going to pick up interference. You get static, you get sparkles on screen.
Or the signal just drops completely.
Right. But fiber is literally glass. It's completely immune to all that RFI and EMI.
So you get zero signal loss.
Zero. NTI's whole claim is crystal clear images with no degradation. That's what you're paying for. Not the materials, really, but the signal integrity.
Let's talk capabilities, then. The specs say it supports HDTV up to 1080p and computer resolutions up to 1920 by 1200.
WXGA.
Yeah.
Yeah, which is pretty standard for DVI. But there's a little detail in there for the real tech nerds listening.
Yeah.
The connectors themselves are male DVI-D dual link. Physically, they're dual link, but the actual bandwidth is capped at 1.65 gigabits per second.
Which is single link speed.
You got it. So it'll fit in the port, but electronically, it performs at a single link capacity. It's plenty for 1080p, but don't expect to drive some massive 4K display with this.
The feature that actually surprised me the most wasn't the lasers, it was the power.
Ah, yes.
Usually, an active cable like this needs a separate power adapter, like a wall wart or a little USB cable to power the chips inside.
Mm-hmm. A huge pain for installers.
But this one doesn't have one. It supports plug and play.
It just sips the tiny amount of power it needs, the 5 volts, directly from the DVI pin on the source computer.
Which is a game changer if you're running this cable through a conduit in a wall or ceiling. You don't have to find another power outlet just for your video cable.
And that leads right into who this is for. NTI's own documentation mentions things like medical imaging and avionics.
Right, high-stakes environments.
Think about an MRI machine. The amount of electromagnetic noise in that room is just off the charts. A normal copper cable would be a snowy mess.
And a doctor needs a perfect artifact-free image to make a diagnosis.
Exactly. Or on an airplane for the onboard video systems. You can't have the pilot's radio causing the in-flight movie to start flickering.
So that $500 price? It's really an insurance policy against physics.
That's a perfect way to put it. For your home office, total overkill. For a TV broadcast station or a surgical suite, it's essential.
It just makes you think about all the invisible infrastructure around us. The next time you see a perfectly clear digital sign at an airport or a sharp monitor in a doctor's office,
there could be a tiny laser firing through a strand of glass hidden in the wall just to make sure that picture stays perfectly still.
And doing it without its own power brick. Amazing stuff.
It really is.
Well, that's it for our deep dive today. Thanks for listening.